AudioBook. Topic: AI technology, exploring infinite knowledge. Author: Levi T. Tzur, A Rock for the World. Table of Contents. Forward page 1. Chapter 1. Introduction to the Knowledge and Evolution of Artificial Intelligence. Page 4. 1.1. What is knowledge, and why is it essential in human life? What is knowledge? Why is knowledge essential in human life? The importance of knowledge in the context of artificial intelligence. 1.2. The birth of artificial intelligence and its evolution from the early days to now. The birth of artificial intelligence, the evolution of artificial intelligence, the future of artificial intelligence. 1.3. How AI has approached, captured, and applied knowledge in various fields. How AI has approached knowledge, how AI has captured knowledge, how AI has applied knowledge. Chapter 2. Foundations of Knowledge and Machine Learning. Page 32.1. User Information Systems and Knowledge. User Information Systems, Knowledge, User Information Systems, and Knowledge. 2.2. Machine Learning and Knowledge Discovery from Big Data. Machine Learning, Big Data, Knowledge Discovery from Big Data. 2.3. Reinforcement Learning and Interactive Processes in AI Learning. Reinforcement Learning, Interactive Processes in AI Learning, the Challenges of Reinforcement Learning. Chapter 3. Knowledge Graphs and Natural Language Technology. Page 43. 3.1. The Semantic Web and Interconnected Knowledge Graphs. The Semantic Web, Interconnected Knowledge Graphs, the benefits of the Semantic Web and Interconnected Knowledge Graphs. 3.2. Natural Language Technology and its role in enhancing AI. The role of NLT in enhancing AI, the future of NLT. 3.3. The importance of understanding and processing natural language for knowledge and AI development. The future of NLP. Chapter 4. Applications of Knowledge in Life and Society. Page 57. 1. Knowledge in Healthcare. How AI and knowledge shape the future of healthcare. Knowledge in Healthcare, AI in Healthcare Challenges, Opportunities. 4. 2. Knowledge in Education. How information technology changes the way we learn and teach. Knowledge in Education, Information Technology in Education. How IT changes the way we learn and teach. Challenges, Opportunities. 4. 3. Knowledge in Business. How AI and data create new opportunities in the business world. Knowledge in Business, AI and data in Business. Challenges, Opportunities. Chapter 5. Challenges in Ethics in Knowledge and Artificial Intelligence. Page 71. 1. Privacy and Information Security Concerns when Applying Knowledge in Life. Privacy and Information Security. Privacy and Information Security Concerns when Applying Knowledge in Life. How to protect your privacy and information security. 5. 2. AI and Ethics. The need for rules and regulations to ensure sustainable development. 3. The importance of dialogue and collaboration between humans and AI. Dialogue and collaboration between humans and AI. The importance of dialogue between humans and AI. The importance of collaboration between humans and AI. Chapter 6. Infinite Knowledge and the Future of Artificial Intelligence. Page 93. 1. New Trends and Evolution in AI and Knowledge. New Trends in AI and Knowledge, Evolution of AI and Knowledge. 6. 2. Smarter interactions between humans and machines. 3. The potential of infinite knowledge and the journey towards a science fiction future. The potential of infinite knowledge, the journey towards a science fiction future. Conclusion. Page 108. Forward. We are living in a time of unprecedented technological advancement. Artificial intelligence, AI, is one of the most transformative technologies of our time, and it is rapidly changing the way we live, work, and interact with the world around us. One of the most exciting potential benefits of AI is the ability to access infinite knowledge. With AI, we can collect and analyze vast amounts of data, identify patterns, and make predictions. This could revolutionize the way we solve problems, make decisions, and learn about the world around us. However, there are also some challenges that need to be addressed in order to achieve infinite knowledge. These challenges include data privacy and security. As we collect and store more data, there's a greater risk of data privacy and security breaches. Bias. AI systems can be biased, which can lead to unfair treatment of individuals or groups. Interpretability. It can be difficult to interpret the results of AI-powered systems. This can make it difficult to understand why the system made a particular decision. Despite these challenges, the potential of infinite knowledge is immense. By addressing the challenges and continuing to develop new technologies, we can make significant progress toward a future where everyone has access to the knowledge they need to thrive. This book explores the potential of AI to help us explore infinite knowledge. It discusses the challenges and opportunities that lie ahead, and it provides a roadmap for how we can use AI to make the world a better place. I believe that this book is an important contribution to the conversation about the future of AI. It provides a thoughtful and balanced assessment of the potential benefits and risks of AI, and it offers a vision for how we can use AI to create a more just and equitable world. I hope that you will find this book to be thought-provoking and inspiring. I believe that it provides a valuable framework for thinking about the future of AI, and I hope that it will help to shape the way we think about and use this powerful technology. Thank you for reading. Chapter 1. Introduction to the Knowledge and Evolution of Artificial Intelligence. 1.1 What is knowledge, and why is it essential in human life? What is knowledge? Knowledge is the understanding of subject or skill gained through experience or education. It is the foundation of all learning and development, and it is essential for human life. Knowledge can be explicit or implicit. Explicit knowledge is knowledge that can be easily articulated and communicated. For example, the knowledge that the earth is round is explicit knowledge. Implicit knowledge is knowledge that is not easily articulated or communicated. For example, the knowledge of how to ride a bike is implicit knowledge. Why is knowledge essential in human life? There are many reasons why knowledge is essential in human life. Here are a few of the most important. Knowledge helps us understand the world around us. It allows us to make sense of the things we see, hear, and experience. It also helps us to understand the complex systems and processes that govern our world. For example, knowledge of the laws of physics helps us to understand how the world works. Knowledge helps us make informed decisions. When we have knowledge, we are better equipped to weigh the pros and cons of different options and choose the best course of action. This is essential for making good decisions in our personal lives, our careers, and our communities. For example, knowledge of the different types of investments can help us to make a wise financial decision. Knowledge helps us solve problems. When we have knowledge, we are better able to identify problems and develop solutions. This is essential for solving the challenges we face in our personal lives, our communities, and our world. For example, knowledge of the causes of climate change can help us to develop solutions to this problem. Knowledge helps us grow and develop as individuals. When we learn new things, we expand our understanding of the world and our place in it. This helps us to become more well-rounded individuals and to make a positive contribution to the world. For example, knowledge of different cultures can help us to become more tolerant and understanding people. In short, knowledge is essential for human life. It is the foundation of all learning and development, and it helps us to understand, make decisions, solve problems, and grow as individuals. The importance of knowledge in the context of artificial intelligence. In the context of artificial intelligence, knowledge is essential for the development of intelligent systems. AI systems need to be able to access and process large amounts of information in order to make decisions and solve problems. They also need to be able to learn and adapt over time. Knowledge is the key to enabling these capabilities in AI systems. As AI continues to develop, the importance of knowledge will only grow. AI systems will need to have access to even more information and be able to process it more efficiently. They will also need to be able to learn and adapt more quickly. Knowledge is the foundation for all of these capabilities. Knowledge is essential for human life. It is the foundation of all learning and development, and it helps us to understand, make decisions, solve problems, and grow as individuals. In the context of artificial intelligence, knowledge is essential for the development of intelligent systems. As AI continues to develop, the importance of knowledge will only grow. 1.2 The birth of artificial intelligence and its evolution from the early days to now. The birth of artificial intelligence. The concept of artificial intelligence, AI, has been around for centuries, But it was not until the 1950s that the field of AI research began to take shape. In 1956, a group of scientists and engineers met at Dartmouth College to discuss the possibility of creating intelligent machines. This meeting is often considered to be the birth of AI research. One of the earliest successes in AI research was the development of the logic theorist in 1956. The logic theorist was a computer program that could prove mathematical theorems. This was a significant achievement, as it showed that computers could be used to perform tasks that were previously thought to be the exclusive domain of humans. In the 1960s, AI research made further progress. One of the most important developments of this period was the development of expert systems. Expert systems are computer programs that can provide expert advice in a particular domain. For example, an expert system could be used to diagnose medical conditions or to provide investment advice. The 1970s saw a period of decline in AI research, as many of the early promises of AI failed to materialize. However, in the 1980s, AI research began to recover, and there has been a steady stream of progress ever since. Today, AI is used in a wide variety of applications, including natural language processing, machine learning, and robotics. AI is also becoming increasingly important in our everyday lives, as it is used in everything from self-driving cars to spam filters. The future of AI is uncertain, but there is no doubt that it will continue to play an increasingly important role in our world. As AI technology continues to develop, we can expect to see even more amazing applications of AI in the years to come. The name artificial intelligence was coined by John McCarthy, one of the participants in the 1956 Dartmouth Conference. The first AI programs were very simple, but they laid the foundation for the more sophisticated AI programs that we have today. AI research has been challenged by a number of problems, including the difficulty of defining intelligence and the lack of sufficient computing power. Despite these challenges, AI research has made significant progress, and AI is now used in a wide variety of applications. The future of AI is uncertain, but there is no doubt that it will continue to play an increasingly important role in our world. The evolution of artificial intelligence. The 1970s and 1980s saw a period of slow progress in AI research. This was due in part to the fact that AI researchers were struggling to develop AI systems that could generalize to new situations. However, there were also some important advances during this period. One important advance was the development of machine learning algorithms in the 1980s. Machine learning algorithms allow AI systems to learn from data and improve their performance over time. This was a significant breakthrough, as it allowed AI systems to become more adaptable and less reliant on hand-coded rules. Another important advance was the development of the Internet in the 1990s. The Internet made it possible to collect and store large amounts of data, which could then be used to train AI systems. This led to a resurgence of interest in AI research in the 1990s, as researchers began to explore the potential of AI for new applications. The 2000s saw the continued development of AI research. One of the most important developments of this period was the development of deep learning algorithms. Deep learning algorithms are a type of machine learning algorithm that can learn from complex data, such as images and videos. Deep learning algorithms have been used to achieve state-of-the-art results in a variety of tasks, such as image recognition, natural language processing, and speech recognition. The development of deep learning algorithms has led to a new wave of excitement in AI research. Deep learning algorithms have the potential to revolutionize a wide range of industries, from healthcare to transportation to finance. As deep learning algorithms continue to develop, it is likely that we will see even more amazing advances in AI in the years to come. The development of machine learning algorithms was a significant breakthrough, as it allowed AI systems to become more adaptable and less reliant on hand-coded rules. The development of the Internet made it possible to collect and store large amounts of data, which could then be used to train AI systems. The development of deep learning algorithms has led to a new wave of excitement in AI research. Deep learning algorithms have the potential to revolutionize a wide range of industries. As deep learning algorithms continue to develop, it is likely that we will see even more amazing advances in AI in the years to come. The future of artificial intelligence. The future of artificial intelligence. AI is full of promise. AI systems are already being used in a variety of applications, such as healthcare, transportation, and finance. Their capabilities are only going to improve in the years to come, and it is likely that AI will have a major impact on our lives in the future. There are many potential benefits of AI. AI systems can help us to solve some of the world's most pressing problems, such as climate change, poverty, and disease. They can also help us to improve our lives in many ways, such as by making our homes more energy efficient, our transportation more efficient, and our healthcare more personalized. However, there are also some potential risks associated with AI. AI systems could be used to create autonomous weapons that could kill without human intervention. They could also be used to manipulate people or to spread misinformation. It is important to start thinking about the ethical and social implications of AI now, so that we can ensure that AI is used for good in the future. Some of the ethical and social implications of AI that we need to consider include transparency. How transparent should AI systems be? Should we be able to know how AI systems make decisions? Fairness. How can we ensure that AI systems are fair and do not discriminate against certain groups of people? Accountability. Who is responsible for the actions of AI systems? Privacy. How can we protect people's privacy when AI systems are collecting and using their data? Security. How can we prevent AI systems from being hacked or used for malicious purposes? These are just some of the ethical and social implications of AI that we need to consider. It is important to have a public conversation about these issues so that we can develop ethical guidelines for the development and use of AI. 1.3 How AI has approached, captured, and applied knowledge in various fields. How AI has approached knowledge. Artificial intelligence, AI, systems have approached knowledge in a variety of ways. Some AI systems are rule-based, meaning that they have a set of rules that they use to make decisions. Other AI systems are statistical, meaning that they learn from data and use that data to make predictions. Still, other AI systems are hybrid, meaning that they combine rule-based and statistical approaches. Rule-based AI systems are based on a set of rules that are manually coded by humans. These rules are used to make decisions about how the AI system should behave. Rule-based AI systems are often used in applications where it is important to be able to explain why the AI system made a particular decision. For example, rule-based AI systems are often used in medical diagnosis systems, where it is important to be able to explain why the system recommended a particular treatment. Statistical AI systems are based on the statistical analysis of data. These systems learn from data and use that data to make predictions. Statistical AI systems are often used in applications where it is important to be able to make accurate predictions. For example, statistical AI systems are often used in fraud detection systems, where it is important to be able to identify fraudulent transactions. Hybrid AI systems combine rule-based and statistical approaches. These systems use rules to make decisions, but they also learn from data and use that data to improve their performance. Hybrid AI systems are often used in applications where it is important to be able to make accurate predictions and to be able to explain why the AI system made a particular decision. For example, hybrid AI systems are often used in financial trading systems, where it is important to be able to make accurate predictions and to be able to explain why the system made a particular trade. The choice of which approach to knowledge is best for a particular AI system depends on the specific application. Rule-based AI systems are often a good choice for applications where it is important to be able to explain why the AI system made a particular decision. Statistical AI systems are often a good choice for applications where it is important to be able to make accurate predictions. Hybrid AI systems are often a good choice for applications where it is important to be able to do both. In addition to the three approaches mentioned above, there are a number of other approaches to knowledge representation in AI systems. These include semantic networks, frames, and production rules. Each of these approaches has its own strengths and weaknesses, and the choice of which approach to use depends on the specific application. The development of new approaches to knowledge representation in AI systems is an active area of research. As AI systems become more complex, the need for better ways to represent knowledge becomes increasingly important. How AI has captured knowledge. The way that AI systems capture knowledge has evolved over time. Early AI systems were rule-based, meaning that they were programmed with a set of rules that they used to make decisions. However, rule-based systems were limited in their ability to learn and adapt. In recent years, there's been a shift towards machine learning-based AI systems. Machine learning systems learn from data rather than being programmed with rules. This allows machine learning systems to be more flexible and adaptable. There are three main ways that AI systems capture knowledge: text and code. AI systems can be trained on large datasets of text and code. This allows the systems to learn the patterns of human language and to understand the meaning of code. Images and videos. AI systems can also be trained on images and videos. This allows the systems to learn to recognize objects and to understand the context of images and videos. Sensor data. AI systems can also be trained on sensor data. This allows the systems to learn about the physical world and to make predictions about the future. The choice of which approach to knowledge capture is best for a particular AI system depends on the specific application. Text and code are often a good choice for applications where it is important to understand human language or to process code. Images and videos are often a good choice for applications where it is important to recognize objects or to understand the context of images and videos. Sensor data is often a good choice for applications where it is important to understand the physical world or to make predictions about the future. The development of new approaches to knowledge capture in AI systems is an active area of research. As AI systems become more complex, the need for better ways to capture knowledge becomes increasingly important. In addition to the three approaches mentioned above, there are a number of other approaches to knowledge capture in AI systems. These include semantic networks, frames, and production rules. Each of these approaches has its own strengths and weaknesses, and the choice of which approach to use depends on the specific application. The following are some examples of how AI systems capture knowledge in different ways. Image recognition. AI systems that can recognize objects and images are trained on large datasets of images. The systems learn to identify the features of objects and images and to associate those features with specific objects. Natural language processing. AI systems that can understand human language are trained on large datasets of text. The systems learn the patterns of human language and to associate those patterns with specific meanings. Machine translation. AI systems that can translate languages are trained on large datasets of parallel text. The systems learn the correspondence between words and phrases in different languages. Self-driving cars. AI systems that can drive cars autonomously are trained on a variety of data, including sensor data, images, and video. The systems learn to identify objects in the environment, to understand the rules of the road, and to make decisions about how to drive safely. The ability of AI systems to capture knowledge is essential for the development of new and innovative applications. As AI systems become more sophisticated, the need for better ways to capture knowledge will become increasingly important. How AI has applied knowledge. AI systems have been applied to a variety of fields. Some of the most common fields where AI is used include natural language processing. AI systems are used to understand and process natural language. This can be used for tasks such as machine translation, text summarization, and question answering. Computer vision. AI systems are used to understand and process images and videos. This can be used for tasks such as object detection, scene understanding, and facial recognition. Speech recognition. AI systems are used to recognize speech. This can be used for tasks such as voice control, dictation, and transcription. Machine learning. AI systems are used to learn from data and improve their performance over time. This can be used for tasks such as fraud detection, spam filtering, and recommendation systems. AI has approached, captured, and applied knowledge in a variety of ways. AI systems have been used to achieve state-of-the-art results in a variety of tasks. As AI continues to develop, it is likely that AI systems will be used in even more fields and will be able to achieve even more impressive results. Here are some additional examples of how AI has approached, captured, and applied knowledge in various fields. In healthcare, AI is being used to diagnose diseases, develop new treatments, and personalize care. For example, AI systems are being used to analyze medical images to detect cancer and other diseases. AI systems are also being used to develop new drugs and treatments. And AI systems are being used to personalize care by tailoring treatment plans to individual patients. In finance, AI is being used to make investment decisions, predict market trends, and detect fraud. For example, AI systems are being used to analyze financial data to identify undervalued stocks and bonds. AI systems are also being used to predict market trends by analyzing historical data. And AI systems are being used to detect fraud by analyzing financial transactions for suspicious activity. In transportation, AI is being used to develop self-driving cars, optimize traffic flow, and predict demand for public transportation. For example, AI systems are being used to develop self-driving cars that can navigate roads and avoid obstacles. AI systems are also being used to optimize traffic flow by adjusting traffic signals and managing lane closures. And AI systems are being used to predict demand for public transportation by analyzing historical data. These are just a few examples of how AI is being used to approach, capture, and apply knowledge in various fields. As AI continues to develop, it is likely that AI will be used in even more fields and will be able to achieve even more impressive results.